See, now I am going to explain the positive error. So where is the positive error? Where should I write? Shall I write here? Here. So in zero errors, the first one is the positive error. Positive error. What is the positive error that we can see? Suppose the Vernier scale 0 is right side of the main scale 0. Then we call it is the positive error. I'll repeat, what is the positive error? If the 0 of the Vernier scale is this one, this is the Vernier scale. If the 0 of the Vernier scale is right side, means it cannot coincide with the 0 of the main scale. So this is the 0 of the main scale. So this 0 of the main scale is not coincide with the 0 of the Vernier scale. If 0 of the Vernier scale is right side of the main scale, then we call it is the positive error. So that is a positive error. Okay, right side means positive error. So positive error. So how you calculate that positive error? Means that positive error is equal to C. So positive error, you can assume it is X. Positive error, that is we can take as X. So how you take that X value? How much? See here, this 0 is not coincide with 0 now. See the Vernier's divisions. These are the Vernier divisions, and this black indicates the main scale divisions. This black line indicates the main scale divisions, and this red line indicates the Vernier scale divisions. Somewhere you can check this Vernier scale division and this main scale division are coincide somewhere else. Where they can coincide, that we have to see. See here, this is one, it is not coincide, it is in between them only. It is not coincide, it is not coincide, it is coincide. Is it correct? So this red means Vernier scale division and main scale division both are coincide here. So what is this? Divisions we can calculate. Divisions means it is 0, it is 1, it is 2, 3, 4. So this fourth division of Vernier scale, don't take main scale. Fourth division of Vernier scale is coincide with the main scale division. In main scale division, where it is coincide, that we cannot consider. But whether the two lines are coincide with each other. Which one? Main scale and Vernier scale reading. These two are coincide with it. That division we have to write. So that is the positive error. So that positive error is equal to 4. Positive error is equal to 4. Right, directly write the 4. Okay. Correction is negative. Error is positive means correction is negative. So now you take the correction. So correction is equal to -4. Correction is equal to -4. Where you can take this correction, I will explain. Okay. First we can take the error. So what is a positive error? You tell me please. What is a positive error?
అంటే
కూర్చునే చెప్పండి.
వెర్నియర్ క్యాలిపర్స్ మెయిన్
పెద్ద చెప్పాలి, ఏం పడాలి ఇక్కడ.
వెర్నియర్ క్యాలిపర్స్ లో
వెర్నియర్ క్యాలిపర్స్ లో 2 స్కేల్స్ ఉంటాయి. మెయిన్ స్కేల్, వెర్నియర్ స్కేల్. మెయిన్ స్కేల్ 0 కనుక, ఇఫ్ మెయిన్ స్కేల్ 0 is not coincide with వెర్నియర్ స్కేల్ 0, then we have error. So when it is a positive error, when it is negative error, we can check it. Suppose the Vernier scale 0 is beyond, means right side of the main scale 0, then we say that it is positive error. How you take that value? Means see the divisions. Wherever the divisions are, one of the division in the Vernier scale is coincide with the main scale division. See here, the 0 is not coincide. Why? Because 0 here, this one is here, black, and it is red, black. Here you see red, black, both are coincide with each other. Means fourth division is coincide with the main scale division. So this is the fourth division of the Vernier scale. That error is equal to, positive error is equal to 4. Directly you can write. Correction is negative. Minus. You have to subtract in the final value. That value where we have to take, that I will tell you. So that is minus. Right. Next, shall I go for negative error? Negative error. What is negative error? That we can see. So negative error means here only come. Suppose this is the main scale. Is it? Shall I draw here somewhere? So I'm going to rub this one. Shall I rub? So main scale I am rubbing. See here. See here. Suppose this is the main scale reading. 0, 1, 2, 3, 4, 5 like this. So it is the main scale reading. Okay. Now take the Vernier scale reading. Suppose Vernier scale 0. Vernier scale 0 is left of the this main scale division. So this is main scale 0. Is it correct or not? And this is Vernier scale 0. Suppose it is left like this. Can you understand what I am telling?
Yes.
So it is left side like this is there. Suppose it is in left side of main scale 0, then we call it is the negative error. Right side means positive error. Left side means negative error. Suppose the Vernier scale 0 is left side of the main scale 0, then we take it is the negative error. So negative error. How you calculate the negative error? See here. Formula is there for negative error. Negative error. Okay. So negative error, you can assume it is as a y. Assume like this. Is equal to minus of n minus x. This is the formula. Minus of n minus x. What is n and what is x, that we have to see. Minus of n minus x. What is n means? That n is the number of divisions in Vernier scale. This we call it is the n. So number of divisions in the Vernier scale. How many divisions are there? 10 divisions. Number of divisions in the Vernier scale is n. And what is x? Coincidence. So which division is coincident with the main scale division? See here also you can calculate. 1, 2, 3, 4, 5th division. See here, 1, it is 0 actually. It is 1, 2, 3, 4, 5th division is coincide. 5th division is coincide with the main scale division. Is it correct or not? These two are coincide like this. So 5th division is coincide, means that x is equal to 5. So finally negative error is equal to minus of 10 minus 5. Minus of 10 minus 5. That is equal to minus 5. So error, negative error is equal to minus of n minus x. N is the number of divisions in Vernier scale. Number of divisions in Vernier scale is equal to 10. Already I told you. And x is the coincidence division of the Vernier scale with the main scale. So I think 5th division is coincide in this case. So minus of n minus 5 means n minus x means minus of 10 minus 5, that is minus 5. Correction is positive. Final value you have to add this one. So correction is equal to, in this case, correction. So correction is positive. You take it is a positive. So for negative error, for positive error, correction is negative. For negative error, correction is positive. I'll repeat. For positive error, correction is negative, and for negative error, correction is positive. How will take positive error? See, where suppose if the Vernier scale 0 is right side of the main scale 0, then it is a positive error. So how you take this value? Wherever that Vernier division is coincident with the main scale division, that division value you can take. That is the positive error. Suppose in this case, in previous case I have drawn 4th division is coincide. So that error is positive, correction is negative. Similarly, negative error. Negative error formula minus of n minus x. What is n? N is the number of divisions in Vernier scale. So number of divisions, how many divisions are there? 10 divisions. That 10 I have taken. Minus, what is x? X is the coincidence division. So coincidence division is 5. So answer is minus 5. Correction is positive. Correction is positive means this you have to take plus 5. Means you have to add the final value. Enough. Okay. Suppose, so positive error is there, negative error is there. One more error is there. That is the third error. So where should I write third error? Here I am writing third error. Third error is 0 error. Third error is 0 error. So it is a positive error, negative error and 0 error. What is 0 error means? See here, suppose it is the main scale. So main scale 0, this is main scale 0. Any doubt regarding this main scale? So like this divisions are there. Each division is 1 mm, already I have written. So 1 MSD is equal to 1 mm, like ordinary scale. Ordinary scale is there no? 30 centimeters is there. Each centimeter 10 mm is there. Like that. It is each 1 mm. Is it correct or not? So this is main scale. It is main scale reading. Suppose this Vernier scale reading is there no? Vernier scale 0. That Vernier scale 0 is also coincide with this one. Which one? This main scale 0. Suppose this main scale 0 and Vernier scale 0 both are coincidence with each other, means both are in the same line. Which one? Main scale 0 and Vernier scale 0 both are coincide with each other, then error is equal to 0. Error is equal to 0. No error. No addition, no subtraction. No addition, no subtraction. When? If it has 0 error. What is 0 error?
Coincide of the
main scale 0 and Vernier scale 0. What is the positive error?
being of the left side, right side kanaka 0 kuntaru.
Yeah. So correction is?
By negative.
Negative. And what is negative error?
Left side kanaka 0 kunte Vernier scale negative error.
Negative error. Correction is?
Positive.
Any doubt regarding this? Right. So main scale is there and Vernier scale is there. In main scale, like ordinary scale, 12.5 centimeters is there. So each division is 1 MSD, one main scale division. Sai, listen please. One main scale division is 1 mm, like ordinary scale. One main scale division is 1 mm. Next, number of divisions in Vernier scale. This is the Vernier scale. It is movable. It is movable on the Vernier scale. So number of divisions on the Vernier scale is 10. Okay, number of divisions. Now we can calculate. We calculated all errors. 0 error means if main scale 0 is coincide with the Vernier scale 0, no error, no addition, no subtraction. What is the positive error? If the
0 lies on right side.
Right side, Vernier scale 0.
Vernier scale 0.
0 right side of the main scale 0. Then it is
positive.
Positive. Correction is
Negative.
very good. What is negative error?
When the Vernier scale 0 lies on the left side of the main scale.
Yes, very good. Right. Left side.
It is negative error.
Correction.
It is in positive.
What is the formula?
Minus n of minus x.
Minus of n minus x. Minus of n minus x. What is n?
N is the
What is n?
Number of divisions of the main.
Number of divisions in Vernier scale. Vernier scale. Vernier scale already I have taken this one. So I have drawn, I think. So Vernier scale will be like this. So Vernier scale is there now. So Vernier scale will be like this. Here divisions are there. Like 1, 2, 3, 4 like this. 11 lines are there. 11 lines. 11 lines means 0. You start with 0. 0, 1, 2, 3, 4 like that 10. So total how many divisions are there? 10 divisions.
10 divisions.
So number of divisions I have taken. Number of divisions is equal to 10. Okay. So it is sliding over the main scale. This Vernier scale is sliding over the main scale. Okay. Now we are going to find out the diameter of the given substance or length of the substance. Now I am going to find out the diameter of this one. Diameter. How to find the diameter, that we can see. So diameter I am going to find out. Okay. So how to find the diameter? Shall I rub these things?
Yes, sir.
Right. Good. Now see here. Now see here. Whatever diameter you have to find out, you take the object between the jaws. These two are jaws. Daudalaga, jaws. So you put that object between these two. Whatever object you have to take, you take this one. Okay. This is the object. This is the object. This diameter you want to find out. Okay. So this is the object. Object. That is object. Okay. Now see these values. Main scale values and these values you can see. So main scale values, suppose, listen. Please listen. So main scale is there. Assume it is 0. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 centimeter. and 1, 2, 3, 4, 5, 6, 7, 9 and here 2 centimeters and so on, like this is there. Now see here, okay, any doubt?
No, sir.
Right, now 2 centimeter and 1, 2, like this is there. Okay, so like this is there, and Vernier scale you can see. So this is the Vernier scale, no? So this is the Vernier scale. This is the Vernier scale. So see the Vernier scale values. Vernier scale value, I'm writing with the red color, see here, red. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 11 lines are there, 10 divisions are there. Any doubt?
No, sir.
Right. Now see, this is the Vernier 0. Okay, you join these two. Where this Vernier 0, where the Vernier 0 is on the main scale reading, main scale division. See the main scale, it is 2. It is 2.1. It is 2.2. For example, it is 2.2. 2.2. 2.2. Okay now? And it is 2.3. Is it correct or not?
Yes, sir.
So I'll repeat again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 centimeter. Until here it is 1 centimeter. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 centimeters. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 3 centimeters. Like this is there. But Vernier 0 is there, no?
Yes, sir.
This Vernier 0 is in between 2.2 and 2.3. Is it correct?
Correct, sir.
On the main scale, it is 2.2. 2 centimeters, 2 millimeter. 2 point. And it is 2.3. But the 0 of the Vernier is in between the 2.2 and 2.3. Any doubt regarding this?
No, sir.
Now you take main scale reading as 2.2, left side value. Means this 0 is not coincide with 2. It is in between 2 and 3. Is it correct? So you take main scale reading. So main scale reading. Main scale reading is equal to in case 2.2 centimeters. Any doubt? 2.2 centimeters. Any doubt?
No, sir.
Right. Now see Vernier coincidence. Next one is Vernier coincidence you have to calculate. Vernier coincidence you have to take. Vernier coincidence. What is Vernier coincidence? See here. It is 0, no? See this Vernier divisions. Which division is coincide with this main scale, that you have to see. Enough. See here. It is the first division of the Vernier. It is not coincide. 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 See here. Somewhere else. This is division. This division is coincide with this one, like this. So whatever the main scale division, that you don't take. But Vernier division is there, no? Which division is coincide with the main scale division? See here, it is 0, 1, 2, 3, 4, 5, 6th. So sixth division is coincide with the main scale reading. Sixth division means this line and this line both are coincide with each other. See here, 0 division is in between 2 and 3, and similarly first division, second division are in between. They are not coincide. But somewhere else, one division is coincide with the main scale division. That division you have to take. That is the Vernier coincidence. So Vernier coincidence is 0. 6. Okay. Right. Now error. Suppose it is a positive error. Suppose for positive error. For example, positive error is equal to 4. Correction is, what is correction? Correction is negative. So in this case, effective Vernier coincidence, effective Vernier coincidence is equal to Vernier coincidence minus positive error. Minus positive error means that this is 6 minus 4. Correction is negative, no? So means effective Vernier coincidence you have to take 2. Suppose error is negative error. Suppose error is negative, let us take 5. Correction is positive. So correction is error is negative, correction is positive, means it is minus and it is plus. Error is negative means correction is positive. Okay, so now effective Vernier coincidence, effective Vernier coincidence is equal to చెప్పండి ఏమవుతుంది, Vernier coincidence plus negative error. Is it correct or not? So that is nothing but, what is Vernier coincidence here? 6 plus 5, that is 1.1, means 0.6 plus 0.5. You do one thing without confusion, you take this negative error, you take it is as a 3, so it is a plus 3. Okay, now 6 plus 3, you take 6 plus 3, that is equal to 8. Negative error you take minus 3, correction positive, that's I told you. Means effective Vernier coincidence is equal to Vernier coincidence plus negative error. So that is 6 plus 3, that is equal to 8. Okay, right. So you know this is mean scale reading and effective Vernier coincidence. Suppose error is 0. Without putting this instrument, first you can find the error, no? Suppose error is 0, next case. This is the first case and it is the second case, and third case I am writing error. So error is equal to 0. Means what is the effective? Tell me, what is the effective Vernier coincidence? Please tell me. That is nothing but simply Vernier coincidence only. So what is that value? According to this, that is 6. Okay, right. So this error I found it, and effective Vernier coincidence I found. Effective Vernier coincidence I found. No doubt at all. Now very very important, least count. Least count you have to calculate. So where should I find? Here. Very important. Least count. Least count. This we call as a LC, least count. Means what is the minimum value you have to calculate by using this Vernier calipers? What is the minimum value you have to calculate in the ordinary scale? 1 mm. Is it correct? For ordinary scale, we are able to calculate until 1 mm. 1 mm, 2 mm, 3 mm like that. So for ordinary scale, minimum value you have to calculate is 1 mm. But by using Vernier scale, what is the minimum value you have to calculate? Minimum value. Least value you have to calculate. That is the least count.
6 plus 3, 9.
6 plus 3, 9. Good. Very good. 6 plus 3, 9. Good. 6 plus 3, 9. Okay. Right. So I'll repeat here again. Least count. Least count means minimum value of the instrument which we have to calculate. For example, for ordinary scale, what is the minimum value you have to calculate? 1 mm. But Vernier calipers, what is the minimum value that you have to find out? That is the least count. So least count is equal to, listen please, least count is equal to 1 MSD. 1 MSD means 1 main scale division divided by number of divisions in Vernier scale. Very important formula. Least count is equal to 1 MSD, 1 main scale division divided by number of divisions in Vernier scale. Again you tell me what is least count?
1 main scale division by number of divisions in Vernier scale.
Right, 1 main scale division divided by number of divisions in Vernier scale. So how many divisions are there in Vernier scale? 10. Right, very good. Now you tell me the least count. What is least count? So least count is equal to, tell me, 1 divided by 1 mm. Is it correct? 1 MSD. 1 MSD, what is 1 MSD? What is the 1 main scale division? Already I have written now. Main scale division is equal to 1 mm. Already I told you, 1 mm, 2 mm, 3 mm. It is like ordinary scale. Also, 1 main scale division is equal to 1 mm. So 1 mm divided by number of divisions in Vernier scale, that is 10. Is it correct or not? 10.
1 by 10.
So 1 by 10. 1 by 10 means least count is equal to, tell me, 0.1 mm. Very very important. So least count is equal to 0.1 mm. If you want to write this one in centimeters, 1 centimeter is equal to 10 power 1 mm is equal to 10 power minus 1 centimeter. or 1 centimeter is equal to 10 mm. That's all you know. So least count is equal to 0.01 centimeter. Enough. Why 0.01? 1 mm is equal to 10 power minus 1 centimeter. So since you write like this, 1 mm is equal to 10 power minus 1 centimeter. Right. So you want to express the least count in millimeter, that is 0.1 mm. Why? Least count is equal to 1 MSD divided by number of divisions in Vernier scale. 1 MSD divided by number of divisions in Vernier scale. So 1 MSD is 1 mm divided by number of divisions in Vernier scale is 10. So 1 by 10. So 1 mm divided by 10. So least count is equal to 0.1 mm. And in terms of centimeters, you want to write least count is equal to 0.01 centimeter. Any doubt regarding this? Right. No doubt at all. Any doubt? So that is least count. Now, how to calculate the diameter of this given object? So this is the given object. Diameter you have to find out. So how to find the diameter means the total reading is equal to, see here. So total reading is equal to, be careful, total reading is equal to MSR plus least count into effective value of Vernier coincidence. Effective value of Vernier coincidence. So total reading is equal to MSR plus least count into effective value of Vernier coincidence. Effective value of Vernier coincidence. What is the effective value of Vernier coincidence means? Again, I will modify this one. So total reading is equal to MSR main scale reading plus least count into, what is effective means? Vernier coincidence plus or minus error. Is it correct or not? When you take plus error, plus if it is negative. When you take minus, if it is positive. So this is the thing. Any doubt regarding this? So for example, in our problem, what is the total reading means? Total reading is equal to, what is MSR? I told you that is 2.2. Is it correct or not? 2.2 you can take, 2.2 in terms of centimeters. 2.2 plus, it is in centimeters only. Is it correct? Plus, what is the least count? That is 0.01 into, is it correct or not? What is this Vernier coincidence plus error? You consider as a positive error, for example. Yeah, correction is negative. What value you got in previous example? I think
0.01 centimeters.
No, with this effective value. 6 you got some value, I think.
0 error 6 వచ్చింది సార్.
Positive error 4 వచ్చింది సార్.
Positive error ఎంత వచ్చింది? 4. Correction -4. చేస్తే టోటల్ ఎంత వచ్చింది ఎఫెక్టివ్? ఇదేమో వెర్నియర్ కోఇన్సిడెన్స్ ఎంత వచ్చింది? 4. 4. ఎర్రర్ ఎంత వచ్చింది?
0 ఎర్రర్ సార్.
0 ఎర్రర్ 6 వచ్చింది. ఎర్రర్ వచ్చేసి 6 వచ్చింది. పాజిటివ్ ఎర్రర్ వచ్చేసి ఎంత వచ్చింది? పాజిటివ్ ఎర్రర్ తీసుకున్నాం కదా.
పాజిటివ్ ఎర్రర్ 4 వచ్చింది, ఎఫెక్టివ్ ఏమో 2 వచ్చింది.
ఎఫెక్టివ్ 2 వచ్చింది, అది నేను అనేది. ఎలా వచ్చింది 2? 4
6 minus 4.
6 minus 4 అది నేను అంటాను. కరెక్టా కదా? ఎక్కడ కోఇన్సిడెన్స్ ఉంది? 6 దగ్గర కోఇన్సిడెంట్ అయింది. ఎర్రర్ వచ్చేసి 4 వచ్చింది ఇనిషియల్గా ఏం పెట్టక ముందు. సో 2. సో మల్టిప్లై చేస్తే ఎంత వచ్చింది చెప్పండి? 2.2 ప్లస్ 0.01 ఇంటూ 2 అంతేనా కదా? సో దట్ ఈస్ ఈక్వల్ టు 2.2 ప్లస్ 0.02. Is it correct? Now we can add it. So 2.2 0.02, add this 2.2 means answer is, total reading is 2.22 centimeters in our example. 2.22 centimeters. Can you understand?
Yes.
మామూలుగా ఆర్డినరీ స్కేల్ అనుకో ఎంతవరకు క్యాలిక్యులేట్ చేయగలరు? 2.2 వరకు చేయగలరు. 2.2. బట్ యూజింగ్ వెర్నియర్ క్యాలిపర్స్ 2.22 accuracy, more accurate value. Any doubt regarding this? So this division we are going to find out. So by using Vernier calipers we can find the second decimal point also, second decimal value. But by using ordinary scale, we cannot find the second decimal value. We can find up to first decimal value. After point, we can find only one decimal value. But by using Vernier calipers, we can find two decimal values. Two decimal values means the second decimal value also. So this is the Vernier calipers. Any doubt regarding this? I will explain again. See, first we have in Vernier calipers we have two scales. One is the main scale and second one is the Vernier scale. Main scale is like an ordinary scale. So each division of the main scale is 1 mm. So one main scale division is equal to one main scale division 1 MSD. One main scale division is equal to 1 mm. Okay. Now go for Vernier scale. So Vernier scale you have 10 divisions. So number of divisions on Vernier scale is equal to 10. Number of divisions on Vernier scale is equal to 10. Now you can find the least count. How to find the least count? Least count is equal to 1 MSD. 1 MSD divided by number of divisions in Vernier scale. Number of divisions means 1 mm divided by 10 means 0.1 mm. In centimeters we can convert 0.01 centimeters. So this is the least count. Adutadu mimmalni. What is the least count of Vernier scale? Enta cheppandi?
0.0.
Right, very good. 0.01 centimeter. Millimeters lo?
0.1.
0.1 mm. Right. So least count vachindi. Now how to find the values? See where this 0 0 of the Vernier scale is on the main scale. Suppose 0 of the Vernier scale is in between 2.2 and 2.3 on the main scale. So you take left side value only. So therefore main scale reading is equal to in this case you take main scale reading is equal to 2.2 centimeters. Means by using main scale we can find only one decimal value. Is it correct? You want to take second decimal value also. How you take that is that you can follow the procedure. So MSR main scale reading plus least count into effective Vernier coincidence. Suppose no error is there, zero error. Initially without putting any object, that is 0 of the Vernier scale is coincident with the 0 of the main scale reading. No error, no addition, no subtraction. Simply you take Vernier coincidence.
Zero.
What is Vernier coincidence? See here. Whatever division is coincident with the main scale division, that division we have to take. That is the Vernier coincidence. So in this case we see 1, 2, 3, 4, 5, 6. 6 is coincidence. 6 is coincidence. Is it correct or not? So 6 you take Vernier coincidence. Suppose error is there. Suppose positive error is there. What we calculated earlier. Positive error. Correction is negative. So here 6th division is coincident. 6 minus 4. That is the effective coincidence. So least count into effective coincidence you can take. So least count is 0.01. In terms of centimeters, this you have taken. So 0.01 into 2, that is 0.02. Any doubt? Right. Now we add this to 2.22. Means by using Vernier calipers, we can able to calculate until the second decimal also. Not only 2.2, 2.22 centimeters. Until the second decimal value also, we can calculate by using Vernier calipers. Any doubts? Do you have any doubts? Please. Advait.
Sir, akkada 0.01 బదులు 0.1 తీసుకోవచ్చు మిల్లీమీటర్.
ఇదా?
mm తీసుకోవచ్చు కదా లిస్ట్ కౌంట్.
ఇది అప్పుడు mm లో తీసుకోవాలిగా. ఇవి అప్పుడు mm లో క్యాలిక్యులేట్ చేయాలి. 1 2 3 4 20 21 22 వస్తుంది. That time you can take 22 into 0.1 into Vernier coincidence. Then also you will get the same value. Same value you will get. Shall I do like that? You take this is 1 centimeter means 10 divisions. 2 centimeters to 20 divisions.
మొత్తం ఓకే ఉంది.
22 divisions వస్తాయి అప్పుడు. 22 divisions. 22 plus 0.1 into 2. అవునా? సో ఎంత వచ్చింది క్యాలిక్యులేట్ చేసి మళ్ళీ సెంటీమీటర్స్లో కన్వర్ట్ చేసానుకో సేమ్ వాల్యూ ఇంకా సేమ్ ప్రొసీజర్. ఎనీ డౌట్? ఎనీ మోర్? సాయి. ఓకే రైట్ గుడ్.